All right, class, let's go ahead and find the horizontal asymptote and the vertical asymptote. So for the horizontal asymptote, we are talking about limit at infinity. So we need to look at limit as x goes to infinity of absolute value of 1 plus x squared divided by x times x plus 1. Okay, so here we are looking at x being a very large number, and actually right here it's a minus. So when x is a really large positive number, 1 minus x squared is going to be a negative number. Okay, so let's think about that for 1 second here. When x is approaching infinity, which is a large number, 1 minus x squared is a negative number, so that the absolute value of 1 minus x squared is its opposite. Okay, because the absolute value of a negative number is its opposite of positive value. Okay, so we would say this is going to equal to limit as x goes to infinity of the opposite of 1 minus x squared is x squared minus 1. And then you would say, well, x squared minus 1 is x plus 1, x minus 1. So then x plus 1 will divide it out, and you'll have just x over x squared over x, and that would be in the form of infinity over infinity. So you can just apply L'Hopital's rule, which would be a limit as x goes to infinity of 1 over 1, which is 1. And even if x is approaching negative infinity, even if x is approaching negative infinity, x squared is going to be a very large number, positive, so 1 minus x squared is still negative. So we end up with the same answer. Okay, so then we would just have y equals 1 is the horizontal asymptote. Okay, so that is how we would find the horizontal asymptote. Now, let's go ahead and find the vertical asymptote. The vertical asymptote is infinite limit. That means we have to check to see about the limit as x approaches some number to the left and to the right. Okay, so if you think about this function right here, the cutoff point really is x equal to 1 is the cutoff point, right? Because if x is actually plus or minus 1, so we're having this right here, negative 1, 1. Okay, so the cutoff point is right in between here, and then this interval here, and this interval here. Now, x squared minus 1 is a negative number out here, but is a positive number in between 1 and negative 1. Okay, so it depends on the value there as x approaches 1 from the left or from the right, or negative 1 actually, right? So we're looking at these suspects here. These suspects here would be x equal to 0 or negative 1. Those are the suspects for your vertical asymptote. So as far as the definition of vertical asymptote go, we need to look at when x is approaching 0 from the right, the limit, as x approaches 0 from the left, and then as limit as x approaches -1 from the right, and then the limit as x approaches -1 from the left of f of x. Okay, so those are the four things that we need to look at to investigate the vertical asymptote. So when x is approaching 0, which is here, 0, either from the left or the right, the inside, f of x, the inside 1 minus x squared is just going to be 1, right? It's just going to be 1. The absolute value of 1 minus x squared is going to be 1. And then on the denominator, we would have positive small multiplied by 1. So then this goes to positive infinity. So we know that when x is approaching 0 from the right, our function goes to positive infinity. And then when x is approaching 0 from the left, again, the numerator is going to be 1. The denominator going to be negative small multiplied by 1, which is going to be negative infinity. So we can see the behavior of the function near 0. When x is approaching 0 from the right, it goes up. When x is approaching 0 from the left, it goes down. So we say that x equal to 0 is a vertical asymptote. Okay, that's the definition of vertical asymptote. Now, let's take a look when x is approaching -1 from the left. Okay, when x is approaching -1 from the left, we're looking at this right here, so that the inside there is going to be a negative number. So then the absolute value of it is its opposite, which is x squared minus 1. And then the denominator is going to still be the same. X is going to be here, -1. And this right here is going to be negative small, because we are approaching, actually, sorry about that, we're approaching, I said from the left, but then I wrote from the right. So this is from the left, and let's say this is from the right, and this is negative small. So then that actually going to cancel out. Actually, let's do this. This right here, x times x plus 1. Okay, so then we can see that x plus 1 is going to cancel out, because this right here, x squared minus 1, is going to be x plus 1, x minus 1. So this is going to be cancel out. So all you have left is x minus 1 over x, where x is approaching -1. So this is -2 over a -1, which is a positive 2. So approaching -1 right here, approaching -1 from the left, your function is approaching 2. So however this function is looking like, it's going towards this number at 2. Okay, and then approaching the -1 from the right, when you are approaching -1 from the right, the value in here, x is a positive number, right? So 1 minus x squared is a positive number, so the absolute value is going to be itself. and itself is going to be 1 minus x squared, which is 1 plus x times 1 minus x divided by x times x plus 1. Either case, this cancel out. However, this is going to be a 1 minus a negative 1. 1 minus a negative 1 is a positive 2 divided by negative 1. So this is equals to negative 2. So approaching from the right, our function is approaching negative 2, right? So there is actually no limit as x is approaching negative 1. But moreover, this shows that because it's not going to positive or negative infinity, that there's no vertical asymptote at x equals negative 1. So we only have one vertical asymptote. Now, if we actually go and take a look at the graph of the function using decimals, this is how it looks like, and maybe this will confirm what the answer is that we got there. Okay, so we are looking at this graph right here, right, where you have a horizontal asymptote right there at 5/2. And then we have a vertical asymptote at x equal to 0, right? Approaching 0 from the right, our function goes way up. Approaching 0 from the left, our function goes way down. Approaching negative 1 from the left, our function is approaching 2. Okay, and approaching negative 1 from the right, our function goes to negative 2. However, that is not a vertical asymptote because it doesn't go to positive or negative infinity. And that is what we have just found here.